come across any question or concept that you want to understand in module 3? Though this is most difficult topic in both the courses that we are doing, 503 and 520. So this is most challenging module among all 12 modules. So you can start asking question. I will start explaining using Minitab and board, whiteboard and slides, whatever.
I do on the mini tab. I was able to do most of it,
Wonderful.
but but um the part that defeated me was the male, and it was I just couldn't get it to differentiate the zero from the one and then break it down into further
Yeah,
parts.
yeah. So, you know, are you using Excel or what?
I used Minitab,
Mm-hmm.
and I was able to create graphs and the pie graphs, and but it was when it came to the what percentage were male and then breaking it down. No, actually, I got that one. It was the age one. 25% was in this age and 75% was this age.
Yeah, Michelle, I explained in the last class, so I can demonstrate right here. So just let me demonstrate. It is related to the last module.
Yes.
Okay, just a minute. So let me share my screen. Can you see my screen? Minitab screen?
Yes.
Okay, now I go and open and let's see when I have Titanic. Okay. And now here I go under statistics, basic statistics, descriptive statistics, and options are none. And I need minimum, maximum. I need first quartile, median, third quartile, interquartile range. So you see, this is this is now let me see if I can draw something on this. Okay. So here we have the data, and let's say this is minimum is 0.17. This is and maximum is 74. Okay. The median is 30. Q1 is 25. Q3 is 38. Interquartile range is 15. So the difference 38 minus this is 15. Now this is first quarter. This is second quarter. This is third quarter. And this is fourth quarter. So means 25, 25, 25, 20. This is the total data. Now the question is, what is the range of or the last quartile? So this is the last quartile. 74 minus 38. So 26 is the range. So, the question are framed based on this interquartile range. I think I explained in the last class that last few questions are based on that. And what is the second quartile? So 30 minus 25, 5 is the difference. What is interquartile range? So this is interquartile range, which comes directly from the Minitab. So these are the different questions that we have. And based on that, you know, uh, you can you can make the decision, you can answer the question. Is it clear?
Yes, thank you.
Mo-
It just makes more sense after I've done it now, and I was able to visualize it and see now I see where I missed a step.
Yeah, I think
So I appreciate that.
most welcome. So did you attend the last session?
Yes, I did, but I hadn't unfortunately looked at Minitab,
Okay.
so it didn't make as much sense until now that, I have worked in it and I did get some stuff done, but this one just kind of tripped me up a little bit.
Okay. So yeah, related to module number 3, if you have any question, please let me know. If no, then I can briefly explain all the distribution. So any question from you?
I haven't gotten too far ahead, but I assume that we're going to be able to use Minitab or Excel for all these functions and that we're not
Yes, we
hand doing
can
any.
we can use. So I'm going to demonstrate one by one. Okay.
Thank you so much. Appreciate it.
So chapter number 6, sorry, I have to clean this. So chapter number 6 and chapter number 7 we are going to cover in this module. What is chapter 6? This is called discrete. Do you know what is the difference between discrete and continuous?
Discrete is going to have like an integer where there's the distinct counts, where continuous is going to be any value.
Yes, that's correct. So perfect, that's great answer. So if I say, I have in my class as of now, how many students are there? If I say we have 19.5 students, no, that doesn't make sense. Either I can have 19 or I can have 20. If I say I have 17.5 cars, doesn't make sense. If I say 2.3 homes I owned, no, they can be 0, 1, 2, 3, means some numbers or some some things, they have only integer value, which are in. I can't say I have 2.3 homes, isn't it? So this discrete means only possible integer number, that is called discrete. Continuous, any number can be possible. Let's say the average age of my class is 22.4 years. I can guess, 22.5. Average age of the average weight of something can be something. Average mileage of my car is, I can say, 22.3 miles per gallon. So continuous means any possible number can be there, and even in decimal. So this is a continuous, this is a discrete. The same difference is observed in chapter number 6 and 7. So discrete, we are doing the probability of event. So the difference in sixth chapter, the x value can be 0, 1, 2, 3, 4, 5, 6, and so on. Means these can be the x value. In seventh chapter, value can be 1.2, can be 2.7, can be minus 1.2. I mean, these values can be possible. So, here, this is the difference between discrete and continuous. Now let's look into distribution, different distribution. So uniform distribution means everything is uniform. So we are just skipping. We are starting with binomial distribution. We have binomial distribution. We have Poisson distribution. We have hypergeometric. we have geometric, and so on. So these are the major items that we major distribution we cover in this. Chapter 7th has normal distribution, standard normal distribution, expon the approximation, Poisson approximation, and binomial approximation. Binomial approximation, Poisson approximation to normal. We have exponential distribution. We have trigonometry, triangular distribution, triangular distribution. Here we have one more distribution which is called uh, how we can convert this binomial to hypergeometric. This is another distribution. So these are the distribution. The most important thing, Minitab can give you the results of your calculation, but first you need to figure it out what is the demand of the question and what is the information given in the question. So two things you need to always look: information given and demand. So if you are able to clear these two things, then you feed the numbers in Excel or Minitab and you get the answer. So let me start with binomial distribution. When do we use the binomial distribution? So first distribution is binomial. You have two situations: yes, no, success, failure, happening, not happening. Let's say, for example, I have 60% chance, 60% chance of taking next week class online. So this is chance of happening this class next week, next Tuesday, 60%. Then what is the chance of not happening? 40%. So happening is 60%, and not happening is 40%. I need to do oil change of my car, but I'm thinking that maybe I will go tomorrow, I will not go tomorrow. So what is the chance? Tomorrow I have a chance that 70% chance that I will go to car oil change, and then 30% chance I will not go. So basically, yes, no, success, failure, happening, not happening. This is the case of, if you see this kind of situation is in the question, then you can assume this is binomial distribution. Is it making sense? So if you see this situation, this is binomial distribution. And three important thing you need for this thing. So three important thing you need to do. N. So if you are able to identify N, you are able to identify P, and X, you are able to. So this is information. This is information if you are able to extract this, and this is demand. Okay. Information. So if you are able to extract these from the question, you will be able to solve the problem. After that, another comes, cumulative and not cumulative, that I will demonstrate little bit later. So look into that, and I'm just pulling the slides so to show you. Can you see my slides part?
Yes.
No, perfect. So, okay, here we go. So discrete probability distribution, there are two other things which I will show you just in 5 minutes. So binomial, you can say happening and not happening arise when, so you can see this, every distribution has this summarized slide that you can look. Mean standard deviation. So look into the very simple, this case. What is the probability that exactly 2 of the next 12 cars serviced are late, where car late is 10%? So late car is 10%, car is not late is 90%. So you can see very simply from this question. Just a minute, let me use the. So here you see n is 12, sample is 12 that we are taking. Cars are late, P or probability is 10%, so which is 10. And so what is the probability that exactly 2 cars are late? So x equal to 2. Now you have this information. We can use any of the situation, any of the tool. Once you figure it out, these numbers, you can use all the tools to do that. I'm going to demonstrate through Minitab, I'm going to demonstrate through Excel, and I'm going to demonstrate through classical way that I learned in my past. So just a minute. Here we go. This is our Minitab. So here you go under graph, you go under probability distribution, and you need to check the just a minute, graph pro. So here when you click this, you see the different distribution. We have binomial. Number of trials are 12, which is n. Event probability is 0.1 10%, which is, now you want to see, oh, we just forget to do one thing. Graph probability view probability, and here you see binomial 12, event probability is 10%. And now we would like to see, since this B are not just, we would like to see x equal to 2. I'm not putting this, the reason is that because it gives the probability of all. So actually this is giving the cumulative. I want to see only x equal to 2. Can you see the, when I put the cursor, it is giving us 23%. You can see this, n equal to 12, when the numbers are popping up, 23%. Okay, let me do the same thing right here in Excel. So I go here, here I do binomial distribution. Here clearly it is saying numbers, trials, probability, and cumulative or not cumulative. So numbers x equal to 2, then comma, trials, we are doing it 12 times. Probability is 0.10, and we put 0 for simple, and we get the, can you see this number? So we get exactly 23%. Now I demonstrate with using one more technique, that is classical. Where's And here we go. Can you see this binomial table? You can get this table at the end of the book. So when you open the book towards the end of the book, you can see. So can you see this table on your end?
Yeah.
Okay, so first thing first, you need to see n equal to, let me make it smaller so it can fit into. So n equal to 12, we have to see n equal to, so we, and this is, the probability, and then this is x value. So n equal to 12, look into n equal to 12, n equal to 12, this is right here. This is x equal to 2 and proportion is 10%. We are going to look into this. 10%, 12, and where is 2 equal to right here, 23%. Okay, so this is the classical way we learned in the past, but now we have all the tools. So this is the classical. But look into when n goes more than 20, we don't have table. We don't have table. The purpose of explaining the concept is that if you have a small n, like up to 15, 16, up to 20, you can use this table. But when you go more than that, every distribution behave as a normal distribution. So this distribution will also behave as a normal distribution, and that can be next chapter normal or continuous distribution, and which is like a z value. So just keep it up to here, how to check binomial distribution. Is it making sense to everyone?
Yeah. Is there a reason why the top ones go to 4 places and the lower ones only go to 3?
Okay, so basically there is no value. So look, here you see, I can demonstrate this. So look into that. After that, the value of the distribution when you put x equal to 4, 5, 6, 7, that becomes 0. So only up to 3, 4, and some. So that is the case. So look into the. So I'm going to demonstrate. Just a minute. Look into that. So I'm just going to show you this table of distribution. So let me put the first x value and the binomial probability. So let me put the x value 0, 1, sorry, 0, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, just I'm putting up to x value 0 to 12. See the probability distribution. So I'm just using the same numbers to demonstrate here. I can go under calculate uh, probability distribution, and I can say cumulative. I don't want inverse probability density function. So, oh, column of values are in C1x. So I want to do binomial, and number of trials are 12. Probability is 10. And now I do okay. Store probability in a column. Here you can see. So probability for 0 happening is 28%. 1 is happening this much. 2 is again that same value which we just calculated, 23. For third, this is. For fourth, this is. But after, 7, 8, these are all zero. So therefore, they have not reported in the table to save the paper or to save the.
Makes sense. Thank you.
You're well. So, these are 3, 4 ways to calculate the probability distribution. Is it making sense? What is important? You need to do n, you need to find n value, pi value, x value. If this is clear, there's one more aspect within this uh, binomial distribution, cumulative. What is cumulative? So let's say if I ask, what is your salary or what is, anyone's salary? So let's say I put, here January, February, March, April. Let's say you have no fixed salary, you have some variable amount in that. May, June, July, August, September, October, November, and December. So you have these 12 months. Let's say you have 10,000 salary in first month. Second month, you got 9,000. Third month, you got again 9,000. Fourth month, you got 11,000. Another month, you got, let's say, 12,000. 15,000. 13,000. 10,000. 8,000. 9,000. And here, let's say 14,000. And here you see 12,000. This is your salary distribution because you have some component is fixed, some is variable. So this is one thing, and which is I can say PDF. Now I say cumulative. So if I go cumulative, here is 10,000. Here you get 19,000. You know how to do cumulative. This plus this is 19,000. This plus this will be here, which is 28,000. Again, 11,000 is 39,000. Plus 12 is 51,000. Please, plus 15,000 is 66,000. Plus 13,000 is 79,000. Plus 10,000 is 89,000. Plus 8,000 is 97,000. Plus 9,000 is 108,000. Am
I
I
think it's
making?
106. 106, 118, and 132.
Oh, where is one? Oh, so this is 89 plus 8 is 97. Where am I making mistake?
97 plus 9 is
Oh, 9, yeah. 97. Yes, thank you.
106.
Yeah, thank you. 106 plus 12 is 118. Sorry. Plus 14 is 130. I think now everything. So this is cumulative. Now I have a question based on this. What is the salary after June? What is the salary before June? What is the salary between June to August? All these questions, if I say what is the salary after June, so I have to add this, all the, next month. If I before June, I have to add all this. Therefore, cumulative cell save our, work. Let me plot the uh, months PDF. And so let me do this and I go under insert and recommended chart. So I go here. So So this is PDF, and let me put the add data levels. Okay, right here. Now I do the same thing with, okay, and now insert. Why? Mhm. How can I do that? Okay, and now insert. This is this one. So add data levels. Now you have two charts. Let me clear this part. Okay, right here. Now I have a question here based on that. What is the salary after June? After June, what I need to do? I need to take this is the total 132 minus up to June is 66. Whatever I get, I can tell this is my salary. After, let's say, what is before June? So not June, before June, I can directly say 51,000. So cumulative is very easy instead of doing. So this is called cumulative. So what is the salary after August, September, October? So basically 132,000 and subtract this and you get the number. So the purpose of cumulative, it's an easy process to get the numbers. Otherwise, you can keep adding the numbers. So look into that. And now I want to see, like, here the question is asking what is the salary of x equal to 2, and you can directly say which is 0.23 from based on. If I ask what is the salary of April, you can directly say 11,000. What is the salary of this? What is the salary of August? You can directly. So this is called PDF and this is called CDF. I'm just explaining in simple terms, with salary. So it is simple. So what is the difference between PDF and CDF? Is like a salary. So the question now is going little bit here. You can see. So this different. Now the question if asked, we did this. I have to clear all these things. Okay, now the question is here. On average, 20% of emergency room patient at this particular hospital lack health insurance. In a random sample of 4 patients, what is the probability at least 2 will be uninsured? So this is not asking only 2, but at least 2 means it is a condition of cumulative. So it is asking, so the range is x equal to 0 means this is it is asking value of at least 2 means it is asking 2, 3 and 4, all 3 together. So insured patient, uninsured is 20% and insured is 80%. So this is clear case of binomial n equal to 4. Here is this x value is cumulative. So here this is the case of cumulative case. Now we do this same using. So again 4%, what is the probability? At least 2 will be uninsured. So I'm just going to pull again this, look into graph probability distribution and I go. Okay. Binomial, what is the number of tries? There are 4 patients. Probability is 20%. Options, we are looking this side. X value is 2, and we are going to get this answer right here. So you can see 2 plus 3 plus 4, all, everything on the right side. The probability is 18%. N equal to 4, probability is 2, but it is asking 2 plus 3 plus 4, and the sum is coming here 18%. And here, so the same thing, because this is adding this percent plus this, which is coming 18%, because this is probability of at least 2. So this is the case is of cumulative, means we are using, what is the probability of less than 2? Patient will be uninsured. If I ask the question, less than 2 means it is asking 0 and 1. Less than 2 means it is not asking 2. It is asking these two numbers. Less than 2 means. So look into that. We have 18% is, 2, 3, 4. What is less than 2? 82. 18% from 100%, automatically you get the answer 82%. And we can do exactly here. So I can go here, I can do the graph, and I can do the probability plot, and I can do the same thing. And here I can choose the option, instead of right tail, I can put the left tail, and I can put the x value is 1, and we can get the answer. So 81.92 is the answer. So this same thing you can do using Excel. So I can show you the Excel. So can you see the binomial distribution? Here, this is the function. Sorry. We have to binomial distribution. Now here clearly asking number of trial is 1. Tries, we are taking 4 sample. Probability is 0.2. For cumulative, we put 1. For PDF, we put 0. For cumulative, we put 1. And you can see the same answer, 81.92% is here. Now look into the binomial distribution table. Okay, pop up. Okay, right here. First, we need to look the n equal to 4. So this is the n equal to 4. P equal to 20. This is the 20. So 4 and 20, this column. We have to see the probability of, so you can see, you can add 0.41 plus 0.41, total is about 82%. So this plus this is the event probability. And this plus this, just you saw, 2 and more than 2. Is it making sense,
Yep.
everyone?
Yeah, so when so when we're putting these into the homework, we have this sheet, and I think Derek asked this question earlier, that has the 3 decimal places, but in Minitab as well as in Excel, it's doing the 4 decimal places. So will we have to round up or no? Okay.
So the answer is no. The reason is, okay, here I give you one simple answer. So let's say let's say the correct exact answer using Excel or coming like here, it was coming 18.08. Oh, this was the probability coming. Okay, from Minitab. You need to put exactly the number, because in Excel, if you see in Excel, there are more decimal with this. So I have given plus minus 5% margin with the answer. Let's say the answer is correct is 100. For this case, I give plus minus 5. That means any answer between 95 to 105 will be accepted if even so answer
I see.
of 100, because somehow you are doing Excel gives more decimal up to, like 10 decimal values. I can
Okay.
understand. So you can put any value will be accepted if it is exact, because if value, like answer is this much, point 0.1, then what should be the difference? So I can add the range is 0.112, little bit, this is upper lane, and lower I can 0.009. Sorry, yeah, this much I can. So means any value will be considered if you are using Excel. Doesn't matter you use 3 decimal, 4 decimal, because value will be accepted.
Oh, okay. Thank you.
You're welcome. So any other question related to this? If not, then the second thing. So this is concept of cumulative, and this is the concept of. Similarly, we have next probability distribution, which is called Poisson. Yeah, this slide is very important. Slide number 26. Please keep in mind what is the meaning of and what is the X value, because here everyone gets confused. What should be the X value? If it is asking more than 2, then what should be the value for X? Because it is not asking 2, it is asking more than 2. That means if it asks more than 2 means 3, 4, 5, all the values. If it is asking less than 2 means not 2, 0, 1 up to here. If it is asking in at least 2 means 2, 3, 4. Fewer than 2 means 0. So please think, what is the value of X that you need to put in the X. It is asking, fewer than 2 means some people ask do up to 2. No, that's not correct. So these small things. So if binomial distribution is clear, we have next is Poisson distribution. So this is whenever you see some information is given in the average terms, average time, average space, or length or something, then you can consider that is a Poisson distribution. Let's say on an average in bank, 20 customer per hour visit the bank branch or credit union. You can say this is on particular airport, 10 flights land per 10 minutes or per hour. On particular space or something related to average, then a Poisson distribution. Is it clear? So this is Poisson distribution, very simple. What is the important for Poisson distribution? Lambda, which is average, is important, and square root of lambda is standard deviation. So lambda and square root of m. So if you have lambda value, you can do. So look into this case. On Thursday morning between 9 a.m. to 10 a.m., customer entered in particular credit union at the mean rate of 1.7 customer per minute. So 1.7 customer per minute. Make sure whenever question information in demand, let's say this is information 1.7 in minute and the answer is asking in hour, then please convert equal dimension. So here per minute 1.7 customer, and here the question can be what is the probability that 2 or fewer customer will arrive in given minute. So the demand is also in minute. So look into Minitab. So now I'm going to do Minitab here. So here I go under graph, probability distribution, and I go here, and here I go Poisson distribution. Mean is 1.7. So this is the only information we need. Then X value. So what is the question is asking? Two or fewer. So X value is two and fewer. So basically it is asking left side and it is asking two. Okay. And now get the value. So if I'm reading question, so what is the probability at least? So here, what is the probability? Then two or fewer customer will arrive in a given minute. Means it is asking two or fewer. So it is asking these three numbers together, and three, you can check the table, you can get the three numbers, you can sum all of them, and you get this number. Or directly you can get this number. This is 0, this is 1, and this is 2, and all three put together is 75.72%. Hope you can see this. So this is here in Excel, you can do very simple. So I go under here, Poisson distribution. Here, right here, the Poisson distribution, and it is asking X value. So it is asking X2. Mean is what is 1.7, and cumulative. Yeah, this is cumulative because it is asking n then, and you give the put insert and you get the same answer. Same thing you can look into the, here is, do we have Poisson distribution? Let me Google. So Poisson distribution table, it is on the back of the book that you have, or you can get anywhere and look into that. So here you can see, let me make it bigger, and how can I make? So lambda, what is the lambda? We have 1.6, we have 1.8. So basically we don't have 1.7 lambda value, but some tables have in detail. So look into that. For example, I'm just looking 1.6. It is asking up to 2. Let me see more. So we can see. Oh, this is a video. This is okay. Here one point here, right here we have the value of, so lambda value. Can you see this 1.7? Now it is asking up to 2, 0, 1, 2. So add 18% plus 31%. 18 plus 31 is 49. 49 plus 26, which is 75. Then 75 point, this 40 and 27 is 67 plus 6. 67 plus 6 is 69 or 70. So basically 75.7. So adding all these three together will make the same answer that we got using this, using where's some mini tab, using this. So same answer. So most important thing in this probability distribution, first you need to identify which distribution is this. Second thing, you need to get the information, what is the information provided. And third thing, what is the demand of the question. And then you can use the Minitab, Excel, table, anything to get the answer. So this is, what is the exact value or PDF, and what is the cumulative distribution. So this is the difference between. So because this is cumulative, if I put this individual value of X value, and corresponding probability, that is PDF. But when you sum together, that is cumulative. So this is this situation. Now we come to the third option, which is called hypergeometric distribution. Hypergeometric distribution is a special case of binomial distribution, where binomial distribution doesn't have finite population. Here we have finite population. So look into. So Poisson distribution is clear to everyone?
Yes, thank you.
Most welcome. Now hypergeometric distribution. The hypergeometric distribution has one extra thing, that here finite population is here, means there are 10,000 people, or there are 10,000 items, or 5,000 items, or 10 items, means this is the population out of which you take the sample, and you can check the probability effects. So whenever you see the total population capital N, then you can assume hypergeometric. But you can convert this hypergeometric to binomial distribution given this situation. Look into that. So few questions are, when sample divided by population is less than 5%. What is the meaning of that? There are 100, there are, let's say, 1,000 students or 1,000 worker in any organization, and you are taking only 50 for, then that situation can be converted into binomial. So please remember, because few questions are given and you will not get the answer in fill in the blanks, you have to check this condition. Again, this condition. First, you need to see the sample divided by population is. So it can be approximated by binomial when, S upon N, when N upon capital N is less than 5%. Okay. So here, in Excel, you can give this kind of, X, N, S, N, and 0, or cumulative for that, you can give 1. So this is the representation, but let's look into this case. There are 10 iPods in shipment, and there are 2 of the iPods damaged and 8 are goods. So Best Buy tests a sample of 3 iPod at random to see if they are defective. So there are 10 iPods, which is capital N. This is a sample because they check a sample of 3. There are 2 damaged in the total population. They are checking 3 iPods. And now see what is the question? At random to see if they are defective. So number of damage in the sample. So basically we are going to look this. So here I can do this using the Minitab. So now I'm going to use simple Minitab for everything that we are learning. So here we go under graph. We can go to probability distribution. We can go. Now we can go hypergeometric. Where is hyper? Population is 10 iPod. Event count, there are 2 defected. Sample size is 3. Option, we are just looking, this, and we are just putting left, and we can see 2 of them just for our. So basically, let me put all 3 so I can see, because we checked all 3. Graph and probability distribution. Since we are checking 3, so let's see what is the distribution function of all 3, and I can put here x equal to 3, and I can do this. So This is the the for 0, there can be 0 defective in the 3 sample. The probability is 46%. 1 defective is also 46%. All 2 defective is about 6%. Cumulative for up to 2 is all 100%. So basically, this is used. So 0 is 46%, 1 is 46%, and 2 is this. So each can be looked into this way. What is the probability that no if you take a sample of 3 from 10 defect, what is the probability that no iPod will be iPad will be or iPod will be defective? 46%. What is the probability that one will be defective? 46%. What is the probability that up to one is defective? 46 plus 46. What is the probability that at least one will be defective? So 46 plus 6, this is the combination. So all different kind of permutation and combination can be possible. So this is the special case of binomial distribution where finite population is given. So this is hypergeometric distribution that you can use in Excel. So rule of thumb, again, this is the rule of thumb that we can do. If n upon n is less than 5%, then you can use the binomial distribution instead of hypergeometric distribution. Means population is very big and sample is small, less than up to 5%, you use this. You use, sorry, binomial approximation. Is it making sense?
Yeah.
Okay, now we have a geometric distribution. So geometric distribution is the special, case where until first success is achieved. Let's say you are doing something, you are running a charity or fundraising event, and people are coming or people are visiting. Which person or what is the probability that seventh person visiting will will donate or will give the funding? So this is here lamb pi is there. At university, 15% of alumni make donation or pledge during the annual telefund. What is the probability that first donation will come on seventh call? Okay. So pi is given here. It instead of doing this is little challenging. Let's do directly on Minitab. So once we understand the demand and information, we use directly graph, probability distribution, and where is geometric? So what is the probability is 15%. Options, and I'm just putting seventh. The reason is that so we can directly put cursor on seventh and we can get the. So here we have up to, this is giving up to seventh, but I'm just putting the cursor on seventh to get the seventh value is about 0.56. So the seventh person will donate, the probability is 0.056, which is 5.6%. So look into the, which is 0.56%, the same answer. So this is the case of this is the chapter number 7, which is 6 related to discrete binomial distribution. Now let's go into the, is it clear, chapter 6?
Yes, I think so.
Yeah. So again, what are the points that you need to make? First thing, to identify what is the distribution, means binomial, Poisson, hypergeometric, or a spatial hypergeometric that can be converted to binomial or geometric. So out of 5 distribution, pick the right one. Then what is the information given? And what is the demand of information, demand of the question? Is it, then check, is it cumulative or it is exactly? The x value can be 0, 1, 2, 3, all integer possibility is there, nothing in between. Now, look into the continuous. So the continuous is, let me put, continuous is continuous probability distribution that any possible value on a scale x value can be there. So basically the, information here, you need to have two most important information, mean and standard deviation. So two important things, if you have mean and standard deviation, and you can put the value of x and you can get the, so the total area under this curve is 1. Look into this. This is most important concept here. This point, this, there's a value or there's a probability on one point, on one single point in discrete distribution. But in continuous distribution, there is no zero probability on single point. If I ask what is the probability on x equal to 2, straightforward 0. So basically what we look into the continuous probability, we always look the area between 2 points. If asked, what is the probability on particular point, then straightforward 0. If asked, between, then you do that. So here is, first thing first, normal distribution. What you need, mu means average and standard deviation, and then you can do all. For standard normal distribution, average is 0 and standard deviation is always, so basically for a standard normal distribution, mu average is always 0 and standard deviation is always 1. So if you remember, the limit is plus infinity to minus infinity, means this curve you can see at this side or you can see on this side, this is not touching the bottom or this is not touching the base. It is going, very close to 0, but it is not 0. Means this range, this curve can go all the way to infinity positive, and this can go all the way to infinity negative. So these are the few property you always remember, that it is not touching 0 or baseline or bottom line. So look into that. For example, we are directly going into the question, minus, so plus minus 3 sigma. We will talk about this. So normal distribution, you can look into we look into the area. So here I am directly going to the question. So look into this. Whenever you know average and whenever you know the standard deviation, you can get the answer very easily. So this class has exam score, average is exam score 86. Sorry. So John took an economic exam and scored 86. The class average is 75 and standard deviation is 7. What is the John percentile, and what percentile John is? We would like to see. So x value is given, mu is given, and standard deviation is given. So let's look. Where is my Minitab? Look into that and I go under graph. Again, same thing, view probability distribution. And we go to normal distribution. Where is now normal? Now mean is 75 and standard deviation is 7. And now we would like to see John, and we would 86 is the score of the John. And let's see. So can you see? So the 86% is John is about 95%, 94 percentile plus. So means 94% pupil or percent pupil, those who were in the exam or in the class, scored less than John. Only 6%, approximately 6% of the student scored more than John. So what is important? Average or mean is important, standard deviation is important, and X value. Okay, now the same question. What should be the score that John should have in order to be in 99 percentile? Mean what should be the score that John should score in order to be 99 percentile? So I can go the same way and I can put, instead of X, I can put the view probability distribution. And now here I can put the, probability, which is I can say 99, and I can put, and I can do that. Oh, I did on the opposite side. I have to select this side graph. And 99, and I think this is the one. So here, so if John could score 5 more points, because he scored 86, if he could score 91 plus something, he will be in 99th percentile. Is it making sense?
Yeah, where did you put 99 in that?
Okay, so
In
here we go, probability distribution, and here, so this is called, here, this is, if you put X value, this is X value.
Oh, okay.
If
I
you
got
put the probability, this is the option. Okay.
Okay, and you have to do 0.99. Okay. All
I
right.
mean, whatever value you need, you can put. So this is,
No, I put in 99 instead of 0.99.
yeah,
And it gave me
yeah.
so.
Remember, probability is also always 0 to 1 range. That is percentage. When we talk about the, this is a percentile case because we divide into 100 pieces of data. So this is percentile. So like you give GMAT exam or GRE exam where you have the average score known of all the students appear, like 200,000 students appeared for GMAT exam, and you can get the average of all 200,000. You can get a standard deviation, and then you have your score. What is your score that you have earned in GMAT? And you can find how many students are before you and how many students are after you in terms of performance, isn't it? And the question is also that, when it comes to the salary interview, and there is a question always asked, what is your salary expectations? And then, we have to give this answer that, in top 10 percentile or top 5 percentile, and from the education, qualification, experience, whatever. So basically, if you give the answer that in previous organization, I was in top 10% and I deserve in top 10% in this organization also, instead of giving exact numbers, so give the ball in their court. So this is normal. What about standard normal distribution? So standard normal distribution has Where's normal? Same thing. But here 0 is this and standard deviation is always 1. And we have all the distribution and all the options here. And now we would like to see 3 and plus minus 3 sigma. So minus 3, I put this, sorry, minus, where's minus 3 and plus 3. And you can see 99.73%. So this is empirical rule that you see minus 3 sigma to plus 99.73% of data will come in this. Same 4 sigma. Okay, and 4 sigma. So here minus 2 plus 2, and that you can say 95.44, 95.44, 4595 points. So this is minus 2, 2 sigma, and we
And
will not.
what was the name of that one?
It's an empirical rule. And this is standard normal distribution when you look into the z value. And option is minus 1. Only normal distribution, what you need to do here, mean is 0, standard deviation is 1. And this is 68.27%. So what is the, sorry, this is chapter 6 and let me go on chapter 6. So a standard normal distribution, this is, here z value is 95th. You can look into z value. What is the area between 1.2 to 1 minus 1.2? What is the area? So we always look into the standard normal distribution about this area. So from here to here, what is the value? From here to here, what is the value? So we always look into this situation. Just a minute. Yeah, this we always like. What is the area between this to this? This is empirical rule 95.44. What is the area minus 1 to 0? So any two value of z is given and you need to find the area. So you just put, upper and lower and you can get the area. So this is, I just explained, minus 1.6 to plus 1.96. And table you can see. So let me show you few more example right here. Just a minute, where is my Minitab? So here this is, now I want to see what is the area between 0 to 2, 0 to 1.5 here. So what I do, I go here, probability distribution, and I do the same thing. And here I check only, I put here 0, 0 means mean in this standard up to 2, 1 point, let's say 5. So we put two values of x. Now we see here what is the, so 0 to 1.5, this is 43%. So you can put any two values. If you want to see here to here, this is 50%, this is 50%. So basically you put the two numbers. This side of the is negative. Just a minute. So this is negative area. This is positive. So here 0 to 1, 2, 3, 4, 3 up to 3. Here you put minus 1, minus 2, minus 3. So basically this side is negative area. Is it all right? Okay. So this is this thing. Now let me go back to, sorry, little bit more time I will take. I think only few of the students are standard normal distribution minus. So here you can see and you can look into if you have average things, and then you have uh, average, and you have standard deviation. Now come to the biggest question. All these Poisson distribution, binomial distribution, they all behave like normal distribution. For normal distribution, you need to have mean and standard deviation. How do we get? If n equal to greater than, so n pi value is more than 10, n 1 minus pi value is more than 10, we use the normal distribution for binomial. The reason is that then how we get the mean and the standard deviation, n and pi is mean, and n pi under root 1 minus pi, and total square root is square root of n pi 1 minus pi. This is standard deviation. So you do this manual thing and you can calculate. So basically you see n equal to 32. Means we see the table of binomial. What is the n? N upper limit is almost 20 over there. After that, when you have sample size, higher sample size, that it becomes normal distribution. Same thing you see in the average. Average is about 20. Lambda is up to 20 is Poisson distribution. You can refer the table, but after lambda is higher than 20 or more than 20, we go to normal distribution. And same thing we do for, so you need to convert average and the standard deviation based on this. This is the must condition. You must make sure that binomial condition, this condition is fulfilled to convert binomial distribution to normal distribution. So look into this. 32 multiplied with 50, which is 16, which is greater than 10. So this condition is fulfilled. Similarly, this condition is fulfilled, then we are going to use normal distribution instead of binomial. Same thing. So here you can see. Now x value is also. So here how we convert this? Similarly, more than 17. So basically in previous case, more than 70, you could use 18 as a x function. But here, since this is in between, we are converting discrete to continuous, we have to convert also a scale, which is more than 17, less than 18. So we take the average of 17 and 18 and we put x equal to 17.5. So x value, so continuous correction, this is called. So x value, instead of putting 18, because in discrete after 17 only 18 is possible, but in continuous, middle center or middle point of 17 and 18 is considered. And rest is nothing, just normal distribution, and just keep doing. Same thing is lambda, lambda, which is Poisson distribution. Here lambda average is, again, average arrival or average something is mu, and the square root of lambda is standard deviation. So same thing you can do for this to convert. So first you need to manually convert these numbers into mean and standard deviation and then convert also x value to make the. Now the second last distribution is called exponential distribution. And remember, the answer, a question is given in lambda form. You have to convert into first same units and these things. So look into this. The question is given here. Patient insurance insurance inquiry arrive at Blue Choice Insurance at 2.2 calls per minute. This is giving minute. What is the probability waiting time more than 30 seconds? So this is giving in minutes. This is 30 seconds for next call. So lambda is 2.2. So basically, what information we need to put here? We need to put 1 by lambda. So So, I have to do 1 by lambda is what? So let's see, calculator, and let me put here. So 1 by 2, where is 1? 1 divided by 2.2. We get 0.44, 0.454545 and all. But this is in second. So what is the minute? 30 second is half minute. So let's see. I go again in the same Minitab and I go under graph, probability distribution, view, okay, and exponential. Where is exponential? And okay, scale is 0.454545. Option, we need to put, this x value is 0.5 because we converted it seconds into, and so 0.66, what is the question asking? What is the waiting time more than? So this is asking on the more than side, not less than side. So we have to choose different side. Sorry. So I go on again. So it is asking more than side, which is, higher side. So, and option is this side. And you can see this is the answer, 0.3329. So exponential is like, one question is given in earthquake related that, you have to convert all the dimension because, that is given in decade and that is asking in 6 months. So you have to make sure to make same scale. So this is 33.29, the same number. So this is exponential. When the next exponential happen, these are the property of exponential. If events per unit of time follow Poisson, the time until next event follows the exponential distribution. Let's say 2020 earthquake happen in last 10 years. What is the probability that next earthquake in next 1 year will be possible? What is the what is the possibility that next earthquake will happen in 1 year? So here this situation is possible. Now we come to the triangular distribution, and this looks like this. Here you need A, B, C, and remember the question is asking this. One of the fill in the blank is asking only standard, so we don't have Minitab where you can calculate. You have to do this manual because you have to have three numbers A, B, C. So if you have A, B, C, you can do this calculation. You can see the area. You can again get the area. And this is triangular distribution. So this is about, I think I covered briefly both the chapters. And how many of you are here as of now? I think 6 of you.
We're few, but appreciative.
Yeah, most welcome. If you have any question, feel free to ask. If you don't have, I mean,
Professor,
yeah,
I just have one quick question.
please.
For clarification, on slide 26, you were mentioning how important it is to pay attention to the wording. That kind of relates a little bit to some confusion I had in last module. And I just wondered if that kind of wording rule maybe didn't apply to finding like the average. So one of the questions about the test scores, it was like 40 less than 50, but less than 50. And yet we took the average by going from 40 to 50. Whereas I think in one of my calculations, I just went from 40 to 49, find the average. So is that different between finding an average when the wording is saying in that wording for that particular question versus the wording for the distribution?
So basically, if this is the question, less than 49, less than 49, if that is the case, probably you are dealing with normal distribution, because n x value higher is there, that means you are dealing with normal distribution. But discrete distribution, if x value is up to 10, 12, 13 here, and you see, because I made different chapters question over there, if chapter 6 fill in the blanks or chapter 6 MCQ that is related to discrete numbers or discrete x values. So clearly, if more than 49, more less than 50, that means x value is 49. But when it is asking in chapter 7, it is you have to correct the x scale in continuous form. So am I able to answer your question, Kelly? Or who asked? Katie, you
Yep.
asked?
Yeah, I think so. Thank you.
Yeah, so I made it very clear because you don't get confused between these two chapters. So separate questions for separate chapters are there in the module. Okay. And few questions, hypergeometric a binomial approximation to hypergeometric is there. So basically, look all these, thumb rule which are given here. Sorry, where is thumb rule of look this rule of thumb. Okay, because 2-3 questions are there related to that. So you need to always focus on this. You need to always focus on n pi and 1 minus pi more than 10 in that normal distribution. So basically, which is in chapter 7. So here, normal approximation, and this is this situation. Okay. So few these rules are important in order to, and this continuous correction. So always look into that. And a straightforward average in the standard deviation is given, then you don't need to just put into the Minitab and get the numbers. Or you can use the tables also. You can use the Excel also, because Excel functions are given in the book. Or here also you can see the Excel function also given. Yeah, this is clearly Excel functions are given, normal, inverse, and all the functions are given on the, here you can see. So basically you don't need to worry that you are not able to get the Minitab or something. Everything are same, but they are different calculators. Answers will be the same. You have 5% margin of error with each question answer. That means you put exact value and your answer will be correct. Don't make rounding number or round up. Don't do the round up. Okay. And yeah, this is what I wanted to say. So all the distributions are there. And if you have more questions, please feel free to ask. Otherwise, I would like to say a wonderful evening and productive week ahead, and we'll see next Tuesday. And there's a probability that 75% I will be there. Then what is the probability that I will not be there?
25.
25.
Perfect. Now you learn binomial. Great.
Thank you.
Most welcome.
Thank you.
Thank
Thank
you.
you.
Bye.